August 17, 1943. 13:47 hours. Regensburg, Germany. Lieutenant Commander Saburo Sakai stood in the briefing room of the 251st Naval Air Group, staring at reconnaissance photographs of American B-17 formations. The images were grainy, shot from a distance, but clear enough. The bombers flew in tight boxes, bristling with guns. "They call it the Flying Fortress," his intelligence officer said. The room smelled of cigarette smoke and stale tea. Outside, the temperature had climbed to 87 degrees Fahrenheit. Inside, it felt hotter. Sakai had shot down 64 enemy aircraft. 64. He'd flown against the best pilots China and America could produce. He'd survived 3 years of combat that killed 90% of his graduating class. He studied the photographs with the careful attention of a man who understood that small details meant survival. "They're slow," he said finally. "Maybe 180 miles per hour at altitude. Heavy, maneuverable as a truck." "Yes, sir, but heavily armed." Sakai nodded. "The guns are the problem, but their bombing accuracy." He tapped the photograph. "Look at the pattern analysis from the raids over Germany. Their bombs scatter over half a mile, sometimes a full mile. They're flying so high they can't see their targets. They just drop everything and hope." He pulled out another photograph. This one showed a German industrial complex after an American raid. Most of the bombs had landed in empty fields. A few had hit residential areas. 2 had struck the actual factory. "This is what we're facing," Sakai said to his pilots. "Heavily armed trucks flying at high altitude, dropping bombs that land everywhere except their intended target. They're impressive in formation. Individually, they're vulnerable. And their bombing? It's terror bombing disguised as precision. They don't have the skill for true accuracy." The pilots nodded. Most of them were young, 19, 20, maybe 21. They looked at Sakai like he was invincible, and he hated that look. "When we engage them, attack from below and behind. Their belly guns have limited traverse. Make one pass, disengage, climb, repeat. Don't get drawn into extended combat. They want you close, where their gunners can track you." "What about their bomb accuracy, sir?" a young pilot asked. "If we're attacking the bombers before they reach their targets—" "Their bomb accuracy is irrelevant," Sakai interrupted. "They're dropping from 25,000 feet through clouds and flak. They're estimating, guessing. Even if they see their target, the wind drift alone throws off their aim by hundreds of yards. No bombardier can account for all the variables at that altitude." He believed every word he said. The math supported it, physics supported it, his own experience supported it. What Saburo Sakai didn't know was that inside each of those B-17s, mounted in the nose, behind armored glass, was a device that weighed 50 pounds and cost $8,000 to manufacture. A device that computed wind drift, altitude, airspeed, temperature, and ballistic trajectory in real time. A device that could place a bomb within 20 feet of its target from 5 miles up. The Americans called it the Norden bombsight. And it was about to prove that everything Sakai knew about aerial bombing was obsolete. 15 years earlier, 1928, a workshop in Brooklyn, New York. Carl Norden was angry. The Dutch-born engineer sat at his workbench surrounded by gears, gyroscopes, and mirrors. His hands, scarred from years of precision machining, assembled a mechanism so delicate that a speck of dust could ruin it. Outside his window, Brooklyn hummed with noise. Inside, he demanded absolute silence. "It's impossible," his business partner, Theodore Barth had said last week, "You can't build a mechanical computer that solves ballistic equations in real time." The tolerances are impossible. The gyroscopes would drift. The mirrors would misalign. And even if you could build it, no one would pay for it. Norden had responded by working 18 hours a day for the next 7 days. The problem was simple, brutal, and unsolved. How do you hit a target from an airplane moving at 200 miles per hour, 5 miles above the Earth, through wind that changes speed and direction every 1,000 feet? Traditional bombsights were glorified guessing tools. A bombardier would look through a scope, estimate the wind, estimate the altitude, estimate the airspeed, then drop the bombs and hope. Accuracy was measured in hundreds of yards, sometimes thousands. Norden believed that was unacceptable. He'd started designing bombsights during World War I. Every design had failed. Too complicated, too fragile, too expensive. The military kept rejecting his proposals. "Good enough is good enough," they told him. "Bombs are area weapons. Close counts." But Norden had grown up in a watchmaking family. He understood precision, and he understood that good enough was the excuse people used when they couldn't achieve excellence. The bombsight he was building now, the Mark XV, was his 7th major design. It used a stabilized gyroscope platform that remained level regardless of the aircraft's movement, mirrors that tracked the target, gears that computed release angles accounting for wind drift, altitude, temperature, and velocity. All mechanically, no electronics. Pure clockwork precision engineered to tolerances of 1/10,000th of an inch. "Carl," his wife called from downstairs, "it's past midnight. You need sleep." He didn't answer. His hands were steady despite the hour. He'd spent 3 hours installing a single bearing. The bearing had to be perfect. Everything had to be perfect. Because he'd made a promise to himself. He would create a bombsight so accurate that a trained bombardier could drop a bomb into a pickle barrel from 25,000 feet. People laughed when he said that. The Navy laughed. The Army laughed. Even his partner laughed. Let them laugh. 1933. Naval Proving Ground, Dahlgren, Virginia. The first test of the Mark XV was a disaster. The bomber, an ancient Martin B-10, flew at 15,000 feet over the Potomac River. The target was a white circle painted on a barge, 50 feet in diameter. Impossible to miss. The bombardier, a Navy lieutenant named James Harper, peered through the Norden sight for the first time. "This thing looks like the inside of a Swiss watch," he muttered. "It is," Norden said from the co-pilot's seat. His voice was tight. Everything depended on this test. "Level the aircraft. Engage the autopilot coupling." Autopilot? The bombsight controls the aircraft during the final approach. It makes micro-corrections. The human pilot can't be steady enough. Harper looked at him like he'd suggested flying blindfolded, but he engaged the coupling. The bomber's controls went rigid as the bombsight's gyroscopes took over, making tiny adjustments to keep the aircraft perfectly level. Harper watched through the sight as the target drifted into view. The gyroscopes hummed, the gears clicked, mirrors tracked the target automatically. "I'm not doing anything," Harper said. "The sight is flying the plane. The sight is computing the release point. When the conditions are perfect, it will signal you." They flew over the target. No signal. The bombsight held the bomb. "It's not working," Harper said. "Wait." 3 seconds later, a light flashed. Harper released. The bomb fell away. They watched it descend. 5 seconds. 10 seconds. 15. The bomb hit the water 73 feet from the target. Harper slumped. Missed. By 73 feet, from 3 miles up. Norden's voice was soft. Do you understand what that means? It means we missed. It means we came closer to the target than any bomb dropped from that altitude in human history. The best bombardiers in the world miss by hundreds of yards. We missed by 73 feet. On the first test, with an untrained operator. Harper looked at the bomb sight with new respect. How accurate can it get? With training? With perfect conditions? Norden paused. 20 feet, maybe less. That's impossible. So is hitting within 73 feet. Yet, we just did it. 1937, Norden Bombsight Production Facility, New York. The device on the assembly line looked like a complex telescope mounted on a gyroscope platform. Hundreds of precision-machined parts. 2,000 individual components. Each one built to tolerances that required special tools to measure. A supervisor walked a new worker through the process. This gear train, he pointed, has to be accurate to 1/10,000th of an inch. If it's off by more than that, the entire site becomes unreliable. How do we measure that? Very carefully. The worker picked up a component. How much does one of these bomb sights cost? $8,000. The worker nearly dropped the part. $8,000? We could buy 3 cars for that. We could buy 3 nice cars for that. But those cars can't drop a bomb through a factory skylight from 5 miles up. The production process was classified top secret. Guards patrolled the facility 24 hours a day. Workers signed oaths promising never to discuss what they built. The bomb sight was considered so valuable that bombardiers swore to destroy it rather than let it fall into enemy hands. The military classified it as more secret than any weapon in the arsenal, more secret than codes, more secret than battle plans. Because if the enemy understood how it worked, they could build countermeasures. Or worse, they could build their own. 1940. Bombardier Training School, Albuquerque, New Mexico. Lieutenant Thomas Farabee squinted through the Norden sight at a target 12,000 feet below. The New Mexico desert was clear and bright. Perfect conditions. The B-17 hummed along at 180 miles per hour. Steady, his instructor said over the intercom. Let the sight do the work. Farabee's hands were sweating inside his gloves. He'd been training for 6 weeks. 6 weeks of learning how to operate the most complex mechanical device he'd ever touched. The Norden had more moving parts than a car engine, more precision than a surgical instrument. Crosshairs on target, Farabee said. Wind? 15 knots west-northwest. The sights compensating. The gyroscopes hummed. The mirrors adjusted. The bomb sight computed trajectories that would have taken a mathematician hours to calculate. The release light flashed. Farabee toggled the bomb release. The practice bomb, a 100-pound weight filled with chalk, fell away. 20 seconds later, white dust exploded on the target. Dead center. Jesus, Farabee whispered. That, his instructor said, is what $8,000 buys you. Do that in combat, and you can take out a ball-bearing factory from 5 miles up. Hit a submarine pen. Destroy a bridge. The Germans think we're carpet bombing because we can't aim. Let them think that. Farabee stared at the sight. How many of us are being trained on this? Every bombardier in the Army Air Forces. By 1943, we'll have thousands of you, all capable of precision that the enemy thinks is impossible. Why don't they build their own? The instructor laughed. It was a cold sound. Because they think it's impossible. Because their best engineers tried and failed. Because they don't believe in spending $8,000 on a single bomb site when they could build a fighter plane for $12,000. That seems short-sighted. It is, but it's our advantage. The Japanese think we're inaccurate. The Germans think we're carpet bombing. By the time they understand what we're doing, it'll be too late. October 14th, 1943, 0800 hours, Schweinfurt, Germany. The ball bearing factories in Schweinfurt produced 52% of Germany's ball bearings. Every tank needed bearings. Every aircraft engine needed bearings. Every piece of military equipment with moving parts needed bearings. The factories were deep inside Germany, defended by 344 anti-aircraft guns and squadrons of fighters. Because the Americans were going to bomb them anyway. Major Robert Rosenthal sat in the cockpit of his B-17 and watched the formation assemble. 291 bombers, each one carrying a bombardier trained on the Norden site. Each one capable of accuracy the Germans didn't believe existed. "Bombardier to pilot," came the voice over the intercom. "Norden site is calibrated and ready." "Roger," Rosenthal replied. His hands were steady on the controls. This was his 8th mission. He'd watched other bombers go down. He'd seen men die. But he'd also seen what the Norden site could do. The formation climbed to 26,000 feet. The temperature outside was minus 40 degrees Fahrenheit. Inside the aircraft, despite heated flight suits, it was barely warmer. Rosenthal's breath frosted on his oxygen mask. German fighters appeared at 10:15 hours, Me-109S and FW-190S. They dove through the formation, guns blazing. B-17S started falling. But the formation held. It had to hold, because the Norden site required steady flight. The automatic pilot coupling required a stable platform. You couldn't evade and bomb accurately. So they flew straight, took the hits, kept formation. IP in 2 minutes, the navigator called. Initial point, the final turn toward the target. Rosenthal's bombardier, Lieutenant Samuel Cohen, took control. The bombsight's autopilot coupling engaged. The bomber's controls became rigid. Cohen adjusted the crosshairs on his target. Factory Building 7. The building was 400 feet long, 150 feet wide. The Norden site computed wind drift, 18 knots northwest. Altitude, 26,400 feet. Airspeed, 182 miles per hour. Temperature, minus 38 degrees Fahrenheit. Ballistic coefficient of the M43 general-purpose bomb. The gyroscopes hummed. The mirrors tracked. The gears clicked. German flak exploded around them. Shrapnel punched holes in the fuselage. The waist gunner was screaming into the intercom, something about fighters at 6 o'clock. But Cohen ignored it. His job was the bomb site. Nothing else mattered. The release light flashed. "Bombs away," Cohen said. 10 500-pound bombs fell from the B-17's bay. They fell for 32 seconds. Gravity accelerated them to terminal velocity. Wind drift pushed them west. The Norden site's calculations compensated for all of it. All 10 bombs hit within a 70-foot radius of Building 7. The building disappeared in a series of explosions that merged into one continuous roar. When the smoke cleared, there was just rubble and fire. "Target destroyed," Cohen reported. His voice was flat, professional. What he didn't say was that they'd just done something the Germans thought was impossible. They'd delivered precision destruction from 5 miles up, through flak and fighters in combat conditions. And they'd done it with a mechanical device that weighed 50 pounds. Same day, 12:47 hours. Luftwaffe Fighter Base, Würzburg, Germany. Hauptmann Hans Joachim. Hajo Hermann listened to the pilot reports with growing confusion. "They're not carpet bombing," one pilot insisted. "I watched their bombs hit. Every bomber in the formation dropped on the same target. The impacts were clustered. Precise." "Impossible," Hermann said. "From that altitude, through our flak." "I know what I saw, sir. Their bombs aren't scattering, they're hitting." Another pilot spoke up. "At Regensburg last month, they destroyed 3 factories with surgical precision. Not the residential areas nearby, not the roads, just the factories. Every bomb group hit their assigned target." Hermann pulled out a damage assessment report. The Americans had hit Schweinfurt. Ball bearing production had dropped by 67%, not from area saturation, from precise hits on critical buildings. "How?" he asked. No one answered, because the only explanation was one they couldn't accept. The Americans had solved a targeting problem the Germans considered unsolvable. They'd achieved accuracy at high altitude that German bombing doctrine said was impossible. "It's luck," Hermann finally said. "Statistical luck. If you drop enough bombs—" "They're not dropping enough bombs, sir. Each bomber carries maybe 10 bombs. The formations are large, but the bomb loads are modest. They're achieving high accuracy with relatively few weapons. That's not luck. That's—" He trailed off. "That's what?" "That's a technological advantage we don't have." November 1943. Japanese Naval Intelligence, Rabo. Commander Minoru Genda read the German intelligence report 3 times. Then he read it again. American bombing accuracy had increased 300% over the past year. Their high-altitude precision raids were destroying specific buildings within factory complexes. Pattern analysis suggested use of advanced targeting systems. German intelligence assessment: probable advanced optical bomb sites with mechanical computing capability. Recommendation: investigate and develop countermeasures. Genda set down the report and lit a cigarette. The smoke drifted in the humid air. Outside, it was 94 degrees Fahrenheit. Inside his office, it was hotter. He thought about Saburo Sakai's confidence, about the assumption that American bombers were inaccurate, about the tactical doctrine built around the idea that high-altitude bombing was area bombing, imprecise by nature. "Get me Lieutenant Sakai," he said to his aide. Sakai arrived 20 minutes later. He looked tired. They all looked tired. The war was going badly, though no one said it out loud. "The Americans have a new bomb sight," Genda said without preamble. "The Germans think it's mechanical, compensates for wind, altitude, temperature, achieves accuracy at high altitude that we considered impossible." Sakai frowned. "How accurate?" "Reports suggest hits within 50 feet from 25,000 feet, sometimes closer." "That's impossible." "That's what the Germans thought. Now their factories are rubble." Sakai was quiet for a moment. "If this is true, our entire defensive doctrine is wrong. We've been assuming their bombers are terror weapons. Inaccurate. We intercept them before they reach targets because we think the bombs will scatter anyway. And if the bombs don't scatter, then we need to stop every bomber, every single one, because if even a few get through, they'll hit exactly what they're aiming at." Genda nodded. "Do you understand what this means? We've been fighting bombers we thought were clumsy. We mocked their accuracy. called them flying coffins because they were easy to intercept. They are easy to intercept. But if they hit what they aim at, the interception becomes irrelevant. A single B-17 that gets through can destroy a factory, a bridge, a ship. We'd need to achieve 100% interception rates to prevent damage. And we both know that's impossible. Sakai crushed out his cigarette. So what do? We fight harder, and we pray the reports are exaggerated. But Genda didn't believe they were exaggerated. And neither did Sakai. December 1943. B-17 formation over the Pacific. Staff Sergeant Michael Romano sat behind his Norden bomb sight and watched the Japanese installation grow larger through his crosshairs. They were bombing a supply depot on a small island. The depot was maybe 200 feet across, surrounded by jungle. Missing it would be embarrassing. "Steady," Romano said into the intercom. The autopilot had control. The B-17 flew itself, guided by the gyroscopes and mirrors of the bomb sight. Wind, 12 knots east. Altitude, 24,000 feet. Airspeed, 178 miles per hour. The Norden site computed everything. Romano just watched and waited. The release light flashed. Bombs away. 8 500-pound bombs fell. Romano watched them through his scope. You could track them for the first few seconds before they became too small to see. 28 seconds later, the supply depot exploded. Secondary explosions rippled through the complex as stored ammunition cooked off. "Direct hit," Romano reported. "Target destroyed." The pilot, Captain Frank Ellis, came on the intercom. "Nice shooting, Romano." "Wasn't me, it was the sight." "Don't sell yourself short." But Romano knew the truth. He'd aimed the sight, yes, stabilized it, made sure the crosshairs tracked properly. But the Norden had done the real work. The computations, the corrections, the precise moment of release. A good bombardier with a conventional sight might hit within 300 feet. Maybe 200 on a perfect day. Romano had just hit within 15 feet, on his 12th mission in combat. That wasn't skill, that was technology. Technology the enemy didn't believe existed. March 4th, 1944. 13:30 hours. Over to Tokyo Bay. Saburo Sakai spotted the B-17 formation at 12 o'clock high, 30 bombers, maybe more, flying in perfect boxes, each bomber positioned to provide overlapping defensive fire. "Attack from below," Sakai ordered his squadron. "Single pass, don't get drawn in." They dove. The Zeros were faster, more maneuverable. Against a single B-17, a Zero had every advantage. Against a formation, that was different. The bombers maintained course, didn't break, didn't scatter, just kept flying straight and level toward their target. That meant one thing: they were on their bombing run. The bombardiers had control. Sakai fired. His cannons hit the lead bomber. He saw the impacts walk across the fuselage, but the bomber didn't fall. The B-17s were tough. Everyone knew that. He pulled up and away. Behind him, his pilots made their passes. They shot down 2 bombers, maybe 3. The rest kept flying. Below, Sakai could see the target, the Nakajima aircraft engine factory. It was huge, sprawling, surrounded by residential areas and secondary buildings. If the Americans were carpet bombing, dropping everything and hoping, most bombs would hit empty space, civilian areas. The factory might sustain some damage, but it would survive. Sakai climbed for another pass. He reached altitude and turned to watch the bomb run. The B-17s were at 26,000 feet. Perfect formation. They flew over the factory complex in a steady stream. Then the bombs fell. Sakai watched through his canopy. He expected the bombs to scatter, to spread across a half-mile radius, to hit everywhere except the actual factory buildings. Instead, the bombs fell in tight patterns. Each bomber's load clustered around specific buildings. The first wave hit the main assembly hall, a building maybe 600 feet long and 200 feet wide. Every single bomb hit the building or within 50 feet of it. Oh. The assembly hall disappeared in a rippling series of explosions. The second wave targeted the machine shops. Same result, tight clustering, precise hits. The third wave hit the offices and engineering section. In 3 minutes, the Nakajima factory was destroyed. Not damaged, destroyed. The buildings that mattered were gone. The surrounding residential areas were untouched. Sakai stared at the smoke rising from the target. His hands were shaking on the control sticks. Sir? His wingman's voice crackled over the radio. Did you see that? I saw it. They hit everything. How did they? I don't know, Sakai said, but that was a lie. He did know. He just didn't want to believe it. The Americans had built a bomb site that made high-altitude precision bombing possible. Everything he'd been told was wrong. Everything he'd assumed was obsolete. Return to base, he ordered. They flew back in silence. March 5th, 1944. Imperial Japanese Navy Headquarters, Tokyo. The conference room smelled of tension and bad tea. Admiral Soemu Toyota sat at the head of the table. The walls were covered with damage assessment photographs. The Nakajima factory, Toyota said. His voice was carefully neutral. Analysis? An intelligence officer stood. Destroyed, sir. Production capacity reduced to 0. Initial estimates suggested we could repair and resume partial operations within 6 weeks. Updated estimates suggest 6 months, maybe longer. The Americans didn't just damage the factory. They systematically destroyed every critical building. How many bombers? 37 reached the target. We shot down 5. 37 bombers destroyed our largest engine factory. Yes, sir? Toyota was quiet for a long moment. Show me the bomb impact patterns. The intelligence officer displayed aerial reconnaissance photos. The bomb craters were clustered around specific buildings, tight groupings. Some craters were within 10 feet of each other. This is precision work, Toyota said. Not carpet bombing, not area saturation, surgical strikes. We believe they're using advanced bombsights, sir. Mechanical computers that calculate release points. The Germans encountered similar performance in Europe. What countermeasures are available? None, sir. We can intercept the bombers before they reach their targets. But if any bombers penetrate our defenses, they will hit what they aim at. Our defensive strategy assumed their bombing was inaccurate. That assumption is incorrect. Toyota studied the photographs. How many critical facilities do we have within range of their bombers? The intelligence officer hesitated. With the way the war is progressing, all of them, sir. Within 18 months, American bombers will be able to reach any target in Japan. And if they can hit what they aim at, no one finished the sentence. No one needed to. Japan's industrial capacity was concentrated in specific factories, specific cities, specific buildings. Dispersed production wasn't feasible. They didn't have the resources or infrastructure. If the Americans could hit individual buildings from 5 miles up, they could systematically dismantle Japan's ability to wage war. One factory at a time. One installation at a time. Increase fighter production, Toyota ordered. We need to achieve higher interception rates. Sir, we're already at maximum production capacity. And the Americans are flying fighter escorts now, long-range P-51s. Our interception losses are increasing. Then what do you suggest? Silence. Because there was no good answer. The Americans had solved a fundamental problem of aerial warfare. They'd achieved accuracy that changed the strategic calculus. And Japan had no counter. April 1944. Luftwaffe Test Center, Rechlin, Germany. Oberst Werner Baumbach examined the captured Norden bomb site with something approaching awe. The site had been recovered from a B-17 shot down over France. The bombardier had failed to destroy it. Maybe he was dead before he could. Maybe he just forgot in the chaos. Either way, Germany now possessed the most secret weapon in the American arsenal. Can we replicate it? Baumbach asked. The engineer, a civilian from Zeiss, shook his head slowly. Not quickly. The precision required. Look at this gear train. Tolerances of 1/10,000th of an inch. Consistent across 2,000 components. The gyroscope platform is stabilized to within 0.01 degrees. The mirrors are polished to optical grade. The manufacturing processes alone would take us months to develop. We have months. No, sir, with respect. We don't. This bomb site represents years of development. Years of manufacturing refinement. The Americans started building these in the mid-1930s. They've had a decade to perfect the process. We're starting from zero. Baumbach stared at the device. It was beautiful in a way, elegant, every component precisely engineered. No wasted material, no unnecessary complexity. How accurate is it? In optimal conditions, 20 to 30 feet from 25,000 feet. In combat conditions, perhaps 50 to 80 feet. Still dramatically more accurate than our best bomb sights. Which achieve what accuracy? 200 feet, under ideal conditions. Combat conditions, 500 feet. Sometimes more. The numbers spoke for themselves. The Americans could hit specific buildings. Germany could hit general areas. Recommendations? Baumbach asked. Disperse production. Don't concentrate critical manufacturing in single facilities. Make them hit 10 targets instead of 1. That reduces efficiency. Yes, sir, but the alternative is watching them destroy our concentrated facilities one by one with surgical precision. Baumbach picked up the bomb sight. It weighed maybe 50 pounds. Seemed incredible that something so small could change the nature of strategic bombing. How much does one of these cost? He asked. American sources suggest $8,000, maybe $10,000 with training and maintenance. And we spend how much on fighter aircraft to shoot down each bomber? The engineer didn't answer, because they both knew. A single Me-109 cost approximately $12,000, and shooting down a B-17 typically required multiple fighter passes, multiple aircraft. Sometimes the bomber escaped anyway. The Americans were spending $10,000 per bomber to guarantee hits. Germany was spending $50,000 per bomber to maybe shoot them down before they dropped. The economics were devastating. Start reverse engineering this, Baumbach ordered. I want a German version in production by autumn. Sir, that's impossible. Then make it possible. But he knew. They both knew. It was already too late. June 1944. B-29 Superfortress, Yawata Steelworks, Japan. Captain Robert Morgan sat in his cockpit and watched Japan slide past beneath him. They were flying at 32,000 feet, higher than any Japanese fighter could reach, higher than most anti-aircraft guns could target effectively. Below, the Yawata Steelworks sprawled across 3 square miles. Blast furnaces, rolling mills, storage facilities. The facility produced 18% of Japan's steel output. Bombardier to pilot, beginning run. Morgan's bombardier, Lieutenant Harold Zelinsky, took control through the Norden site. The autopilot coupling engaged. The B-29's controls went rigid. Zelinsky watched through his scope. The gyroscopes hummed. The mirrors tracked. Wind, 14 knots southwest. Altitude, 31,800 feet. Temperature, minus 48 degrees Fahrenheit. The Norden computed, adjusted, compensated. IP in 30 seconds, Zelinsky said. Japanese flak exploded around them. The bursts were too low. The gunners were aiming for standard bomber altitude, 25,000 feet. The B-29 flew 7,000 feet higher. 10 seconds. The crosshairs centered on Blast Furnace 3, the largest furnace in the complex. Destroying it would cripple steel production for months. 5 seconds. The release light flashed. Bombs away. 12 500-pound bombs fell. They fell for 38 seconds. Wind drift pushed them west. The Norden's calculations had already compensated. Morgan watched through his cockpit window. The bombs were invisible at this altitude. Just wait for the explosions. When they came, they were perfect. All 12 bombs hit within a 100-foot radius of Blast Furnace 3. The furnace collapsed. Secondary explosions rippled through the complex as molten steel spilled. "Target destroyed," Zelinsky reported. Morgan keyed his radio. "Lead to formation, target hit. Follow bombing run as briefed." 47 more. B-29S dropped their loads. Each bombardier guided by a Norden sight. Each bomb precisely calculated. Each impact within meters of the aim point. When the formation turned for home, the Yawata steelworks was gone. Not damaged, gone. "How many missions before they rebuild?" Morgan asked over the intercom. "They won't rebuild," Zelinsky said. "Why would they? We'll just come back and hit it again, with the same accuracy, from the same altitude. They can't stop us." Morgan was quiet, because Zelinsky was right. The war had become mathematics, and America had better calculators. August 1944. Saburo Sakai's personal journal. "I was wrong. We were all wrong. The Americans don't bomb inaccurately because their crews are untrained. They bomb accurately because they possess technology we cannot match. I watched them destroy the Nakajima factory with 37 bombers. 37! We would need 300 aircraft to achieve the same result. Maybe more. Every assumption we made was incorrect. We thought their high-altitude bombing was area bombing, terror bombing. We were fighting them with tactics designed to counter imprecise weapons. But their weapons aren't imprecise. I shot down 64 aircraft in this war. I was an ace. I thought I understood air combat. I thought I understood the limitations of bombing at altitude. The Americans have no such limitations. Or rather, they've overcome the limitations through engineering. How do you fight an enemy that hits what they aim at? How do you defend against precision delivered from heights you can't reach? I don't have answers. No one does. September 1944. German Industrial Production Ministry, Berlin. The production statistics told a story of systematic destruction. Ball bearing production, down 67%. See Sunits. Aircraft engine production, down 58%. Synthetic fuel production, down 73%. Sano. Tank production, down 44%. Each percentage point represented factories destroyed by American bombers. Not but carpet bombed. Destroyed. Specific buildings eliminated with surgical precision. Minister Albert Speer stared at the numbers. He'd been warning about this for months. No one had listened. "We dispersed production," his deputy said, "just like you ordered. Moved manufacturing to smaller facilities. But they just hit those too. They find every facility and destroy it. Methodically. One by one." "How accurate are their bomb sights?" Speer asked. "Captured documents suggest 20 to 50 feet from 5 miles up. Our intelligence initially dismissed this as propaganda. Now we know it's accurate, perhaps conservative." "And our own bomb sights?" 200 feet under optimal conditions, 500 feet in combat. We can't match their precision. Speer walked to the window. Berlin was gray under heavy clouds. Somewhere up there, American bombers might be flying, planning their next target, computing trajectories with mechanical precision. "What's the strategic implication?" he asked. "Germany cannot sustain concentrated industry under these conditions. Every major facility is a target they can hit reliably. Dispersing production reduces efficiency, but is necessary for survival. However," the deputy hesitated. "Say it." "Dispersed production is less efficient. Our output drops even without bombing, and they're hitting the dispersed facilities anyway. We're losing both ways." "What do you recommend?" "End the war. Negotiate. Because we're not going to outproduce an enemy who can destroy our factories faster than we can rebuild them." Speer turned from the window. "That recommendation is noted and rejected." But privately he agreed. The numbers didn't lie. America's precision bombing was dismantling Germany's industrial base with mathematical certainty. They'd changed warfare, made strategic bombing genuinely strategic, turned bombers from terror weapons into surgical instruments. And Germany had no answer. November 1944. American bombing assessment, European theater. The statistics were unprecedented. Pre-Norden accuracy, average miss distance of 1,200 feet from high altitude. Post-Norden accuracy, average miss distance of 180 feet from high altitude. A 7-fold improvement. 7-fold. Mission effectiveness had increased proportionally. Targets that previously required 500 bombers could now be destroyed by 80. Missions that once needed multiple strikes could be accomplished in a single raid. American bomber losses were decreasing because the formations could strike from higher altitudes, with fewer aircraft, shorter exposure to defenses. The Norden bombsight had done what strategic planners claimed was impossible. It had made precision bombing at high altitude genuinely precise. Colonel Curtis LeMay reviewed the data with quiet satisfaction. He'd been a vocal advocate for the Norden site when many considered it too expensive, too complex. $8,000 per bomb site, his deputy said, compared to $12,000 for a fighter, $20,000 for a bomber. The return on investment is extraordinary. "It's not about investment," LeMay said. "It's about capability. We can hit ball-bearing factories, synthetic fuel plants, engine manufacturing. The Germans have to disperse everything, which reduces their efficiency. They're